Welcome to this Cycle Machine Learning Tool tutorial. In this session, we will use the Logistic Regression Classifier to solve a multi-class, multivariable classification task. Our dataset is the newborn health monitoring dataset, which contains medical and demographic information collected from the newborn. The goal of this project is to predict newborn health status, identifying whether the baby is healthy, at risk, or critical. By the end of this walkthrough, we'll see how logistic regression can handle classification challenges and how we evaluate its performance. Before training the model, we must carefully pre-process the dataset. This involves handling missing values, encoding categorical variables such as demographic information, and scaling continuous features like temperature and heart rate. Pre-processing is a critical step because machine learning models require input to be consistent and numerical. Without it, the classifier may misinterpret the data or give biased result. By standardizing the dataset, we ensure the logistic regression model learns from meaningful comparable inputs. The target variable in this dataset is the newborn's health risk level, categorized into three groups: health, at risk, and critical. This is the outcome that our model is trying to predict. The input features include a combination of demographic details such as gestational age and birth weight, along with critical monitoring data like oxygen saturation, temperature, and heart rate. Additional screen result, for example, generalized levels and reflex tests, also contribute together. These features provide the model with a rich set of signals to determine newborn health outcomes. Logistic regression is a simple yet powerful algorithm for classification tasks. It works by combining input features into linear equation, then applying a sigmoid function to estimate the probability of belonging to a certain class. For problems with more than two classes, the model uses softmax function, which produces probability across multiple categories. In our newborn dataset, the classifier assigns probabilities to each health status, healthy, at risk, or critical, and selects the class with highest probability as the prediction. This makes logistic regression both interpretable and effective for medical classification problems. Once the dataset is ready, we split it into 80% for training and 20% for test. The logistic regression model is trained on the training set, where it learns relationships between the input features and health outcomes. After training, the model generates predictions on the test set. We then evaluate its performance using the F1 score, which balances precision and recall. This evaluation method is especially important when class distribution is uneven, ensuring a fair measure of performance across all categories. Now let's go through how to use Cycle Machine Learning web app to implement this task. First, let's name our project here, and then let's write a brief summary of our project. And in the data type drop-down column, we click tabular, as our data is in CSV format. And then we click upload CSV and click on this button to upload our CSV data. After successfully uploading the data, we can see the summary of our data on the table tab, and also a summary of each column on the data tab. Now let's go to the pre-processing step and select our target label, which is the risk level column. And then let's click machine learning algorithm. And then let's choose our classification model. And then let's choose our evaluation metric, which is the F1 score. And then let's click perform. So after a few seconds, we can see our F1 score is 0.28, which means our model was able to accurately predict the result with our input feature. Although the F1 score is not very high, but it can accurately predict the result with very fast speed. Thanks for watching.